Hey everyone, we are starting today with something very different because this is not an archived release, not a processed image from days later, and not a reconstruction assembled after the fact. This is a live space capture recorded only minutes before it was shared publicly. Just minutes ago, during the closest approach window of 3i Atlas to Earth, a fresh image surfaced from Brazil. This was captured in real time, around 6 in the morning, coordinated universal time, at a moment when distance, illumination, and viewing geometry were changing rapidly. This timing alone makes the frame important, because it places the observation right at the point where subtle physical responses become visible. The raw capture came from Diego San Araujo in Brazil, and the refinement and stabilization were done by Amar. The capture used approximately 30 times zoom and was refined to an 8K output, preserving structure without aggressive enhancement. What matters here is not just resolution, but restraint. Nothing was added, nothing was forced. The star field was preserved exactly as recorded. This was live data. Captured live, shared within minutes, refined conservatively, and released while the object was still in motion. That sequence matters because it removes many of the uncertainties that often surround amateur imagery. Delayed sharing, heavy stacking, or artistic enhancement can all obscure physical reality. This frame avoids those traps. Now let us slow down and talk about what the image actually shows. The object appears as a bright, condensed source with a clearly defined surrounding glow. The central region is strong and non-diffuse. It does not smear outward or dissolve into noise. Around it sits a soft halo, consistent with a coma produced by active outgassing under solar illumination. And equally important is what we do not see. There is no spiral structure, no chaotic plume, no turbulent expansion. The coma remains smooth and controlled rather than explosive. That detail is easy to overlook, but it is critical. The background star field remains fixed. Stars hold their positions relative to each other while the object moves independently across the frame. This immediately eliminates several common explanations. This is not lens flare, because lens artifacts move with the optics. This is not sensor noise because the signal is spatially coherent. This is not a background galaxy because the object's motion relative to the stars is unmistakable. What this strongly supports is a real, active cometary body surrounded by a solar-illuminated particulate cloud. Now pause here, because this is about 1 minute into the discussion, and this is where context matters. Avi Loeb has repeatedly emphasized that the most important moments in science occur when observations do not fully match expectations. Not when something looks dramatic, but when it behaves calmly in a way models did not forecast. His recent discussions about 3i Atlas focus precisely on this point. Anomalies are not conclusions. They are signals that classification may be incomplete. Keep that framing in mind as we continue, because timing changes everything. This image was not captured after hours of stacking or reinterpretation. It was recorded live, refined without artificial object insertion, and preserved with original star alignment. This is exactly how real discovery chains begin. Raw data first, refinement second, verification last. Now let us address the reported distance. The distance value, approximately 268.5 as stated by the source, is exactly that, a reported figure at capture time. Further work is required to verify the units, cross-check ephemeris data, and match the observation against tracked orbital solutions. This is not a weakness. This is standard scientific process. Science does not begin with certainty. It begins with careful verification. Now we step back and connect this live image to space tracking logic. Space tracking systems do not react to headlines. They do not chase dramatic visuals. They quietly flag deviations in motion consistency, brightness stability, structural symmetry, and environmental interaction. Most objects pass through these filters without comment. 3i Atlas does not. When the refined amateur image is examined alongside space tracking methodologies, it raises a legitimate anomaly proposal. Not because it proves something extraordinary, but because it does not behave visually like a routine, fast-moving object. This is where science begins. At what does not quite fit? From the refined image, several features stand out clearly. The central brightness remains compact. There is no explosive coma expansion. There is directional asymmetry without turbulence. The surrounding star field remains undisturbed. Most fast-moving bodies near close approach show chaotic interaction signatures. Brightness fluctuates. Material sheds unevenly. Tails distort. Profiles look messy. This one does not. When space tracking models compare expected behavior to observed behavior, a mismatch emerges. Expected behavior includes variable brightness, irregular shedding, and tail distortion driven by rapidly changing solar conditions. Observed behavior shows stable luminosity, clean directional bias, and minimal dispersion. That mismatch is the anomaly. Light behavior adds another layer. There is no rapid flaring, no fragmentation glow, no pulsed intensity spikes. Space tracking systems classify this pattern as low interaction transit, an object moving through space without aggressively reacting to its environment. That is uncommon. And again, clarity matters. This does not imply origin. This does not imply intent. This does not imply artificiality. The proposal is narrower and more disciplined. 3I Atlas may represent a class of fast transit object whose material response and energy behavior differ from the small bodies that dominate our existing catalogs. In simpler terms, incomplete classification. Right now, confidence sits in an unresolved zone. Enough certainty to rule some explanations out, not enough data to rule everything in. And here is the critical irony. This anomaly becomes visible because the data is clean, no overprocessing, no forced color, no dramatic enhancement, no artificial contrast, just signal. And that signal refuses to look messy. History gives us a useful perspective here. Most discoveries begin as anomalies. Most anomalies disappear as data accumulates. A small number redefine categories entirely. You do not ignore anomalies. You document them, you track them carefully. This is why live amateur astronomy matters. Again and again, amateur observers have contributed to early comet detections, near-Earth object alerts, and independent confirmations before official catalogs were updated. Timing and honesty often matter more than equipment size. This frame deserves follow-up, not dismissal. And now we arrive at the open question. If an object moves cleanly, emits stable light, and shows minimal interaction with its environment, is it behaving exactly as expected? Or are our expectations shaped by too narrow a sample of past observations? As solar interaction continues to increase, what happens next will matter. Does the coma expand? Does the brightness destabilize? Does the structure finally break down? Or does it continue to behave in a controlled, low-interaction way? We do not need answers today. We need continuity of observation. Credit matters. Raw data matters. Timing matters. This is how space is really observed. Live, imperfect, and honest. Let me know which detail from this live capture stands out to you the most. And if you're tracking 3I Atlas through this closest approach window, stay with it. The next frames may tell us far more than any theory ever could.